Now let us try to learn about symmetric key cryptography. So these are the various concepts that we are going to go through. Symmetric key cryptography started thousands of years ago when people needed to exchange secrets, mostly in wars. But now we are currently using it in network security to a great extent. So in traditional ciphers, we have two different versions, and here we are concentrating on symmetric cryptography. So in all the various types that we see here, we are always going to keep in mind that the same key will be used in the sender end and the receiver end. So we have traditional ciphers. In this case, we have two different categories. We have substitution ciphers and transposition ciphers. And in substitution ciphers, we are going to go for monoalphabetic, or we are going to go for polyalphabetic. Now what does it mean? So let us try to understand it one by one. Substitution cipher replaces one symbol with another. So by symbol we mean it may be character, number. If we have a message with us, it is going to comprise of characters and numbers. So what we are going to do is, suppose we take alphabets. So a single alphabet will be replaced by some other alphabet in from the plain text. So in a plain text we are going to have lots of alphabets. So we are going to consider the replacement of those alphabets by some other alphabets. So let us try to understand how to do that. So here we have an example here. The question is it monoalphabetic or not? So before going to the question, so what is monoalphabetic? When we have a particular alphabet and we want to substitute by some other alphabet, and it is a one-to-one relationship. So that means H will be substituted by some other alphabet, and E will be independently substituted by some other alphabet. But they are all going to follow a certain rule. So let us try to see what rule is followed here, or what strategy is followed here. So H to K. So if we consider the 26 English alphabets, so H, I, J, K. So from H we jump 3 times to go to the alphabet, and we are going to substitute H with that alphabet. So we have E, F, G, H. Again 3 jumps, then L, M, and O. Same L, M, and O. And from O it is going to be R. Please ignore this T here. It has nothing to do in the slide, but anyways, just ignore it. So what has been done here is, whenever we consider a single alphabet, we are doing 3 jumps. In the English alphabet, we are trying to do 3 jumps to go to a new alphabet, and that alphabet will take the place of the earlier one. Alright, so it is very simple. Of course, in certain cases we have to be very sure what to do. For example, like if you are considering, suppose X, then if we have X in the plain text, then X, Y, Z, A. So from Z we again have to come back to the first alphabet. So it's like a cycle, in order to continue with the last few alphabets. So it's like a rotation, because of course there is going to be limitation of any alphabet. So if we come to the end, then we can again go back to the first alphabet to have a rotation. Alright. So if you do examples on this, you will have a clear picture of what happens. If we go more mathematically, it's modulus of 26 for English alphabet and so on. But now let us keep all the things very basic enough. Let us keep it very simple. So this is monoalphabetic, yes, because here you can see, from whenever we have a L in plain text, we are always replacing it by another alphabet, which remains same. What I mean by that is, whenever we have L, we are always replacing it by O. So L, O, L, O, and so on. So that means that there is a complete mapping that has been done with the alphabets individually. Alright, so it is monoalphabetic. Then, but in this case, if you see, it is H, E, L, L, O. But in case of L, for the first L we have N, for the second L we have Z. So that means we don't have a common jump here, right? We don't have a common jump, right? So here we can say that it is not monoalphabetic. We can simply say that it is not monoalphabetic. There must be some other strategy that has been used. There are lots of algorithms to show as an example, but right now you just need to remember that if it is monoalphabetic, then a same letter will always be replaced by the same other letter, right? but if it does not happen, then of course it is not monoalphabetic. But if I go back to the previous slide, it says that the cipher is probably monoalphabetic. So here, though every time L is replaced by O, still we cannot say 100% that we are always considering monoalphabetic, because in certain other cases, by coincidence, it may happen that L became O for two different instances, but we are not going to consider those complex scenarios here. Here we can say that probably yes, this particular example follows monoalphabetic, and in this case it does not. So the shift cipher is sometimes referred to as the scissor cipher. So you can go back to history pages to understand how scissor cipher, or how the scissor is related to the cipher. Most of the time, whenever we have three jumps from alphabet to a substituted alphabet, we consider it as scissor cipher. Okay. Then here we take another example where we have HELLO. In case of earlier example, we jump 3 times, but here we have to jump 15 times. So from H, you have to jump 15 times in the English alphabet to get a new alphabet, and this H will be replaced by that particular alphabet. Okay, that's why it is very important to understand that if we somehow reach the end of the alphabets, suppose X, Y, Z, then if we have to consider the next alphabet, we have to again start from A. Okay, so it's like a cycle. So please remember that, and as an exercise, you can just try to convert from hello to this particular output. If you are able to do so, then you have understood what it basically means. Okay, so in the earlier case, the key value was 3 because we did 3 jumps. Okay, and in this particular example, the key value is 15 because we have to do 15 times. Okay, we have to jump 15 times. Alright, this is a key because it will be secret. Okay, it will be secret because if you look at the earlier example, simple example, in the sender side, hello has to be sent. Okay, so this when this hello is converted into ciphertext and sent to the receiver must know that it again has to reverse jump 3 times to get back the plain text. Okay, so this information will only remain with the sender and the receiver, and that's why since 3 jumps are required, either forward or backward, it is a secret, right? So it is considered as a key. Okay, so in this example, the key is 15. Okay, it will only be known to the sender and the receiver. Okay, then only sender can encrypt hello to this particular message, and the receiver can again get back hello from this particular message. Okay, so this is done in the next example. Actually, we got the output here, which is a ciphertext. Now we again have to use the key value of 15 in order to decipher back the message. Okay, and here we have to reverse jump 15 times to get back hello. So I request students to take pen and paper and try to see if you can convert from WTAD to hello. Okay, take it as an exercise. If you cannot do, just let me know. We are going to discuss. Okay, so then we come to the next concept, which is a transposition cipher. Okay, in case of transposition cipher, as the position signifies or indicates, we are going to change the positions of the characters or letters or symbols in the plain text. Okay, we are just going to change the positions of the symbols. We are not going to substitute with new symbols. Okay, so here we are just going to do permutation. So if you remember permutation, we just change the positions of the symbols. Okay, so it can be numbers, it can be alphabets, but in our case we are mostly taking alphabets. But yes, a message can comprise of letters, symbols, numbers, etc. Right? So it can be anything. In case of transposition, we are just going to change the places. Okay. So let us take an example to understand transposition more clearly. So here we have a plain text and we have ciphertext. Okay. So we have a sender and a receiver. So the sender is going to take this plain text and then it is going to apply this key in order to create the ciphertext. And this ciphertext will go through the network, and then the receiver is going to do the reverse. Okay. The receiver is going to do the reverse. But what is it going to do? So let us try to understand that. Suppose a particular message comprises of maybe 4 symbols, okay, or 4 characters. Okay, so we have 1, 2, 3, 4 as the positions of the particular word. So we are going to take the first character or first symbol to the 3rd place, the second symbol to the 1st place, then the 3rd symbol to the 4th place, and the 4th symbol to the 2nd place. Now when we do this kind of jumbling, okay, we get a new output, and that output is going to be the secret message that is going to go through the network. Okay, so once it goes to the network, the receiver is going to do the reverse. It is going to again shift the 4th symbol to the 3rd place, then third symbol to the first place, then second symbol to the fourth place, and the first symbol to the second place. So the reverse is going to be done in order to get back the plain text. All right, very simple. So here we have an example here. Here suppose the sender wants to send hello my dear. So in this case what we are going to do is we are going to somehow make the message be divisible by 4, because if we have 4, then we can easily fit in this particular key. Okay, we can easily fit in these places to get back the new transposed message. Okay, but the problem is if we discard the spaces, then how many characters do we have? We have 1 2 3 4 5 6 7 8 9 10 11. We have 11 symbols here, and we require something that is divisible by 4. So what we can do is we can add a bogus character here or bogus symbol here, and we consider Z in this particular example. So you just add a Z in the end, so that we can easily break down the sentence into chunks, and each chunk each chunk have 4 symbols. Okay, so each chunk has 4. Okay, I repeat once again, so that each chunk has 4 symbols. Okay, so we have HELLOMYDEARZ, so it becomes 12. So after it becomes HELLO then MYDEARZ, what we are going to do is we are going to cut the particular sentence, not a sentence, I would say it becomes a word because there is no more spaces. So that word is again going to be broken down so that each chunk has 4 characters. Okay, which are HELL, then OMYD, then EARZ. Okay, and then one by one each of this particular word is going to be put in this particular key, and then it is going to be converted into a new word. Okay, so if we put HELL here, then this H will go to this, then E will come to the first place, then L will go to fourth place, and L will go to the second place, right? So we get ELHL, and rest of the things are also done in the same fashion. In the next round we are going to send OMYD, and in the last round we are going to send EARZ, and we are going to easily obtain the output. Fine. Now the reverse can also be done the same way. So suppose the receiver has received the message, so what it is going to do is it is going to take 4 characters at a time or 4 symbols at a time, and then again put it in this particular box in this particular place, and then it is going to do the reverse. Okay, so if we have ELHL, so what it is going to do is it is going to place ELHL. Okay, and then you will see that once they go back to the places, we get the original word, okay, which is HEL. All right, so the reverse can also be easily done in order to obtain the plain text. All right, so this is all I have to say now. This next topic is more related to a different algorithm called DES, so we are going to study that or discuss that in the next session. Thank you.